Okay, so we're going to move into section 3.1 and 3.2. And we're going to start looking at basically, how do I say this? Visualizing data. So we're going to look at some distributions, and we're going to start to look at different types of graphs that you can do. Some of the basic ones, we're going to look at bar charts today and pie charts today. So, and we'll go into more a little bit later on. So we're going to start getting into a little bit more of how we can show data and how we can classify it in ways that make sense to people. So the first thing we're going to look at is what's known as a frequency distribution. So a frequency distribution is basically a chart that organizes data into classes. Those classes can be anything. So remember, we had two different types of data. We have quantitative and qualitative. A frequency distribution can be done with either one of those, because you can literally have hair color and then how many of red, green, blue, black, brown, whatever, listed next to it. That would be a frequency distribution. So to construct it, you just got to choose your classifications and count how many is in each one of those classes. All right, so it's pretty straightforward and simple to do. It's actually normally one of the first things everybody does is when they try to organize data, they take it all and they organize it into some kind of class system. If it's numbers, we can normally do lists. So it's like we'll say all the ones from 0 to 10 or 10 to 20 or 30, like those type of things. Those are also classes that we can use. So if we were to take, hide this for a second, all of the, this table is showing the population of individual states in 2010 and 2016. So when we're looking at this, it's given us not the whole list because there's 50 states and this don't feel like listing them all, but it gives us some basic information there. Now, what are some of the ways that you might want to organize this data? Okay, so we might be able, so when we're taking, this is a list of all the data. So when we're taking, we want to try to make some frequency distributions. We wouldn't necessarily list it alphabetically, but we could do by geographic region. We could take all the east ones and all the northeast and southwest and those type of things. So we could definitely look at that. Oh, that's not what I wanted. There it is. What's some other way that we could possibly list this by classes? Okay. Again, not quite a frequency distribution. What's the difference between just a list and a frequency distribution? Because I think that's the piece we're missing. What's the difference between the two? Yeah. All right. Okay. So this is a list. This is a frequency distribution. So notice now we're taking that data and organizing it. Not necessarily just in a list. We're not looking at all of them. We want to know how much of something is happening within those categories. So my classifications or classes are the change in population, which is what you said, but you were just going to list them all. We're now taking them and we're classifying into groups. So below 0, 0 to 1.9, 2 to 3.9. So basically 2 all the way up. So every 2%, they're going to give us 1. And then we count how many is in each of those areas. What's the other negative one? Oh, they actually were wrong. There's 3 of them in the negatives. Just looking at the actual full list because I wanted to know the states that were in the negative. There's actually 3 states in the negative, not 2. Anybody want to take a guess what they are? Which states do you think lost population from 2010 to 2016? Texas increased by almost 11%. Connecticut was basically zero. It was 0.1 growth. North Carolina up almost 6.5%. North Dakota up almost 13%. So here's an interesting thing. North Dakota. Who's going to go to North Dakota? The difference with North Dakota is their population was so small, they only increased by 85,000 people. But when you start off with 672,000 people, that's a big change. So like Texas was very similar, but they went up by almost 3 million people. But since their population was so large at the beginning, the population change, that's that percent, has to have a bigger number. It was Illinois, Vermont, and West Virginia were the 3 states. So Vermont only lost like 1,000 people, but their population's small. So that's the difference in there. So that's when we're looking at, this is just a list. It's listed by in alphabetical order, so it's an organized list, but it's not a frequency distribution because there's no classes there. And this was just one of the ways. We could have easily done it by geographic region and added the population. So those are the types of things you want to look at when we're looking at the difference between the two. When you're looking at frequency distributions, the goal is to organize the data and be able to easily look at what's going on. Almost every survey that you would do is a frequency distribution because you're going to ask questions and you're going to check off which option they gave you. Those options are your classes. So if we look at this one, these were 2 questions. If I remember right, this survey was done. They were asking about education. And these were the first 2 questions they asked. They asked 1,250 people. And it says, in general, how would you rate the quality of American public schools? And that was the frequency distribution. They gave excellent, pretty good, only fair, poor, or not sure. So while you would think, okay, there's no difference in that in a list, the list would have listed all 12,000 or 1,250 people and their option, their stat next to it. That would have been the list of all the data. Not very useful. When I put it in a chart like this, my frequency distribution becomes a little more useful. We can start to see trends. We can start to see what's going on. Yes?
So what would the definition of frequency distribution be?
A frequency distribution is a summary technique that organizes data into classes and provides a tabular form, a list of classes along with the number of observations in each class. Simply, it's a table with classes instead of all the data. And then all you're doing is you're counting them up. Do I have a mark? Got it? Because I'm going to switch for a second. All right, so let's go. We've got pink, gray, black, cream. And actually, you know what? I'm just going to do white. Makes it easier. White, blue, white, black. Anybody know what I'm listing? Yeah, it's your shirt colors. Or approximately your shirt color. So this is a list. green, black, blue, blue, gray. Okay, I was gonna say it's gray or black. I couldn't tell. It's in the corner. All right, that's just a list, right? Now, the frequency distribution. I'm actually gonna change. I think we had two pinks. Yeah, we did. Okay, fine. So we have pink, gray, black, white, blue, green. I think that's all the colors. Oh, and red. Those are now my classes. Now I count. So we have 1, 2 pink. 1, 2, 3, 4, 4 gray. 1, 2, 3, 4 black. 1, 2, 3, 4 white. 3 blue. 4 green. And 2 red. That's a frequency distribution. Okay, see the difference? So now it's organized. So now we can go, not that we're going to get much information out of this. Apparently most people like the blacks and the white, the basic colors. All right. So now we have something that we can actually use. We can put it into a chart. We can put it into a pie chart. We can put it, well, can't put that in a pie chart, a bar graph. Show you what you can do with the pie chart in a second. Okay. Everybody get the difference between a list and a frequency distribution now? Big thing. Okay. Now, so there's our frequency distributions. So this is another one that we have here. What's the difference between this one, the one that we just looked at there, and this one? Yes.
The one is whole numbers and the other one is percentages.
Okay. So what this one's called is a relative frequency distribution. The only difference is it's divided. It's divided by how many people actually took the survey. So in this case, they were dividing it by 1,250. Why is it useful? So why is it useful to put it in percentages?
You get a better idea of what's more popular.
Okay. Well, if you look at one that's 700, couldn't you just look at the numbers and say the biggest one's the most popular one? Why is percentages helpful? That's partially. That's what. Yes.
When you have big enough like subject group, it'll give you an idea of what the general population believes.
Okay, so we can start using it to compare things. The other thing is, so yeah, go ahead.
It'll always go like 100 a whole, rather than the frequency distribution where it's just like a bunch of numbers.
Yeah, so we like things that are round numbers. So it's like we can look at things. Okay, I know this is out of 100. Most people can visualize that. One of the things you did in elementary school when you're like cutting up pizzas and stuff like that, you can start to visualize how big things are. The big thing that you can do once you get percentages and why it's called relative is that you can compare it to other studies. So I looked at 1,250 people. Maybe another study did it out of 5,000 people. If I was just looking at the raw numbers, the 5,000 people were like, okay, they're going to blow us out of the water. There's way more people that like this. Once I put them in percentages, it's all out of 100. So I can compare different groups, which is helpful. So we have our frequency distribution and we have a relative frequency distribution. The relative frequency distribution would allow me to do it as a pie chart because now there are percentages and it's out of 100. So we can easily do that part there. All right, so all they did to change from this to that. So if you take 462 and divide it by 1,250, see real quick. Because I'm hoping it comes out to be the way they said it was. Yep. You get 0.3696, which rounds off to 37%. So to change it, all you do is divide it by the total number of surveys or people that you looked at. How would you rate quality of public education? Interesting
Very
question.
poorly. I'm an early childhood education major, very poorly.
So you're trying to fix the problem. Well, hopefully fix the problem.
I know you're not from Connecticut, but there have been
I
so
am.
many, or not Connecticut, Norwich.
Oh, yeah.
There have been so many protests and stuff recently, just in Norwich. Like,
Yeah, I don't know why.
protests.
I was gonna say I don't know. Like I've seen them, but I don't know why because I didn't hear any. Like I've heard other controversies that other cities would cause this, but I'm like,
So the superintendent is basically a hot mess and like made like 150 teachers quit, and then instead of like the school board calling her out on this, they gave her a raise,
Oh,
and she like won't help anyone. And multiple people, so many people have been having problems with like their kids being bullied, school giving out private information about children to schools where those children aren't attending, like all this stuff. And parents are going to the school board and they're like, "Hey, we're having a problem," and the school board dismisses them completely. It's so
That-
bad.
that would definitely do it. So
Like one woman's son who's in seventh grade, another kid took a video of him in the changing room, and they, instead of like getting the kid who took the video in trouble, they suspended the kid who complained, whose video had his video taken, and then the one teacher who was there who like saw everything got fired.
well,
Well, that makes sense.
that part makes sense.
Right?
Like maybe not fired, definitely something. Yeah. Oh, yes. Public education. There's some issues. There's some definitely issues in public education.
In high school, there was a kid who got punched in the face by somebody else who had a roll of work in their hand. And so he hit the kid back, obviously. And the one who was defending themselves got expelled, and one who went to court got suspended. Yeah, the one who got arrested and like charged with assault only got suspended. The one who was defending themselves got expelled.
Ay.
Like, don't forget the kid at NSA, like, years ago, got, so bad, he had brain injury. And the school was ignored it, and on the rug, didn't get medical attention until his freaking hospital, and got hospitalized, getting brain surgery.
Okay. Sorry, I asked that question. No, I understand that. It was like, yeah, just what ask that question during class. I'll ask it afterwards. So yeah, there's definitely but according to this survey, most people think it's pretty good. The vast majority was excellent or pretty good. As a former teacher in high school, I will totally say this is the number one thing that will make a difference in your child's education. You have to be involved in your school, and not just to sixth grade. Because parents are really involved with their kids when they're in elementary school and stuff like that. When they get to high school, they basically just stop worrying about things. Be involved with your kids' life through the entire career of school. And I'm willing to bet most of you that's the same thing. It's like you got your parents yep, good. As long as your report card comes good. We don't really care what's going on. No, definitely be involved. That's the number one thing that will help your child succeed in school, no matter what. All right, and I'm glad that whoever took the survey realized that. I want you to. So this is signs of Parkinson's. Parkinson's, yeah. I can't pronounce it correctly. It's not Parkinson's. It's Parkinson's-ism. I want you to change this to a relative frequency table. Oh, wait, I got to give you one other number first. I have to tell you how many people.
Wouldn't that tell us how many people took it? If it's not
Hmm.
relative.
Yes and no. This is out of 467 people. There's a reason for that. But I say so. Divide them all by 467. Yes. They looked at 467 people for this. Oh, I'm actually going to show you something.
So how would we do that exactly?
210 divided by 467. That's what you're doing for the first one. So the first one you should get 45%. When you do 210 divided by 467. And then 153 divided by 467. It's 33%. %. Yes.
Aren't percentages supposed to add up to 100?
Ah. It's going to be one of the questions I'm going to ask in a second. All right. I want to show you something real quick, though. One of the calculators you should definitely download and have on your phone is Desmos. So there's two versions of it. There's the graphing one and there's the scientific one. You really won't need the graphing one in here, but the scientific one is very handy. One of the cool things that you can do with it, one of the things that we're going to use this actually quite often for, is you can type formulas into Desmos and then type in the values. So for example, this one I said x divided by 467. Now this one was pretty simple to do, but then I can literally just change the x. So it was 210. What's the second one? 53. And then I can just change it to 153 and I get the number, and I can change it to 84 and I can get the number. So it's like I can literally just change that and it will give me the new value. It works for any formula. And we're going to actually use this to do our standard deviation formulas and stuff like that. So we'll type the formula in and then we'll just type the variables in underneath it. And you can easily change things to see how things change. Okay. So I would definitely, I would highly suggest downloading this to your phone. You will be able to use it on the tests on your phone. So definitely something to use. Desmos, D-E-S-M-O-S. It's totally free and it's the best calculator on the market. It won't do your work for you like MathWaves and those things, but it will. It's a calculator that will do a lot of stuff for you. All right. So back to this. So the question is why don't they add up to 100? Any nursing majors in here? Or anybody in the nursing and medical field at this point? Why don't they add up to 100? Yes. Yes. They looked at 467 people. You can have more than one. You could. So that's why they don't add up to 100.
See, I knew that was a very
That's why when I said, oh, just divide. And I'm like, wait, you can't do that yet. I have to give you the number. Because if you were to add them up, they would have added up to 100. The problem was then you're going to be looking at more people. So, however, even though it doesn't add up to 100, it doesn't mean this doesn't give me good information. Okay. I can't make a pie chart out of it because pie charts have to go up to 100. But I can easily make a bar chart out of this and those type of graphs. And you can sit there and look at, okay, reduced arm swing and slow finger taps are the two largest symptoms that you're going to see. So if you see somebody with any of those in a shuffling gait, that's probably a good thing because that's one of those ones that doesn't show up very often. Okay, so it's like those are the types of things you can now get good information from this. So, all right. Good questions. This is why when we're looking at it, it's like you ask, it's like, okay, that doesn't make sense. Why? The interesting thing is, and I don't know why, left leg rigidity was more than the right leg rigidity. I don't know why. Maybe it's something about where it happens in the brain because it switches sides to the brain when you're going through and looking at it.
Like a lot of stroke happen.
Yeah. And then it affects the right side of the body. If it's in the left side of the brain, it affects the right side of the body.
It's a lot of people that have, it depends on stroke disorders. Stroke is a lot of like left side paralysis.
Mhm.
And then, yeah, I forgot the other.
Yeah, so it'll happen because it's your brain's weird. They literally control the opposite sides of the body, and I don't understand why. So yeah, if it's like left side paralysis, the stroke actually happened to the right side of the brain. So, because my grandfather had a stroke, and that he was paralyzed on his right side, so he had to drive. Literally, he drove with a suicide wheel after a while. It's like that's what he did. Wouldn't see that nowadays. All right. Let's look at some charts. The two charts that pretty much everybody knows are bar charts and pie charts. Bar charts and pie charts both have to be made from frequency distributions. Okay. So, because if you don't have it listed as a frequency distribution, you do not have your classes. And therefore, you can't organize how much something happens. This bar chart, is this a frequency distribution bar chart or a relative frequency distribution?
Relative
Why?
percent.
Yes, it's the only difference. If I was to put the actual frequency distribution there and just use regular numbers, would the bars change? Would the lengths of the bars change if I put the actual numbers down there instead of the percentages?
It'd be smaller. It would be different.
Would they? So if something, let's see, so one's just about 60 and one's just about 30. So very serious happens to be twice as much as the somewhat serious, right? Approximately.
Yeah.
So even if I did the actual numbers, wouldn't they still be about the same difference?
Well, it would be relatively.
I know.
Relatively speaking. So if I put actual numbers, it'd be 700 and 325, right? So that's a little less than half of it. So the bar still would be almost twice as long instead of 56 and 26, which is the same concept, right? So the bars necessarily actually would change. The bottom would change.
Yeah,
But the bar, the relationship between the bars wouldn't change.
that's what I meant.
Yeah. So they might change slightly depending on how you break up your numbers and stuff like that, but the relationships wouldn't change. So you'd still have that big of a bar compared to the next smaller bar down. So frequency distributions and relative frequency distributions when you go to bar charts are very similar in what they look like. Okay, so they won't really change too much. The only difference is it's how you are looking at the numbers and how you would actually talk about the numbers in that respect. Remembering back to what we talked about last Thursday, is this a good graph? Or is it misleading? You don't necessarily need to go. I understand what you're saying, but you don't necessarily need to go to 100. Well, yeah, you could go. Yeah, I could see a little bit of that. Normally they don't go all the way up to 100% just because it's the white space. You typically don't like a bunch of space at the ends of your graphs and stuff like that. So normally, like here's a good example of a two bar charts that show the exact same data. So this one starts off at 0, goes to 250. This one starts at 180, goes to 210. That's definitely a deceiving graph. It's designed to show a much different thing there. The crazy thing is when you look at, even if you were to expand it out to 100 on this one, the relationship between the bars still stay the same. And that's the big difference between when you're looking at a deceptive graph and not a deceptive graph is the relationship between the data accurate? So in this situation, even if I doubled it, the relationship between these two bars, this would still be twice as big as that one. Where in this one, the actual representation is the bars are pretty close, where this one looks like William or Beth made like 4 times as much as Susan did. So the relationship between the bars is skewed in this respect. Okay. Raise your hand if you know how to make a bar graph. Good. So I'm not teaching you how to make a bar graph. All right. I will honestly say, until I looked in the book for this class, I have never heard this name before. I've seen these graphs before. It's a bar graph. Apparently, it has a specific name though, and the only reason I'm throwing it in is because I know the lessons on Hawk sometimes they will use specific names, and I want to make sure you know the name because it could come up. You will not have to tell me this name on the test. It's Pareto. Basically, it's a bar graph where the bars are organized in descending order. So you can look at, well, actually, we'll go that. What's one of the advantages of this type of bar graph? Yep. And you can look at the bottoms to tell those immediately. So if they were all mixed up, so if we go back to like this and they're all mixed up, it's a little harder to figure out which one's the best one. I'd have to look at each bar. Where if they're in this order, I can easily look at, oh, India's number 1. So that's helpful. Right? Yeah, this is going to the movies. So India's number 1, United States is 2, and China's 3. And then pretty much everybody else after that's not really that big of a market. Huh? Yeah. Which is actually why, like, when they look at the box office for movies, it's really the United States and everybody else. Now they start to represent China a little bit more because they see them. Our American movies don't do that well in India right now. India's got Bollywood, and that's their huge thing. So American movies just do not do well in India. But most of our movies, like China, is the next big market that they look at to release the movies in. So that's why you see the U.S. market and then the worldwide market. That's basically it. All right. That's the end of that chart. This one you do see quite often. This is known as a stacked bar chart. So a stacked bar chart allows us to organize the data in a way that'll make it a little easier to understand. So in this graph, this is the Olympic medal count for the Winter Olympics in 2014. Which country had the most medals? Russia. Anybody remember where the Winter Olympics were in 2014? It wasn't Russia. In a very warm part of Russia. You think Russia is very like they did it in like the warmest part of Russia. I don't not know why. Yeah, but it was in Russia. So, but we can start to look at now. What's the one that they represent? What's the one that's most important on this graph? Why would gold be the most important on this graph? Okay. But I could have put anything at the bottom. So when you're actually rephrase it. That's why it's at the bottom. You can tell what's the most important one. Like this one, obviously bronze medal, silver medal, gold, silver, and bronze. There's ranks to those. You can tell the most important part of a stack bar graph by whatever's first on the bottom, because that's the only one that you can visually see the change over the time. So like if you look at this, the next one's silver. It's like, okay, that's big, that's small. Like it's really hard to determine who got the most silver medals because it's not ordered that way. Like you can quickly look and tell who got the most gold medals. The other ones would be harder to do. All right. So when you're creating a stacked bar graph, you want to put the most important data at the bottom and then stack the other information on top of that. If I didn't do this as a stacked bar graph, I could do it as this, or I can do it like this. This is the same data. Each one's its own bar. Shows the same information, but it's not as clean. And you can't tell quickly who won the medal count. So same data, just different ways to look at it. The one nice thing about this one as compared to the other one is it's easy to tell who had the most bronze medals or who had the most silver medals because they're individually listed from the bottom. Okay. Those are bar graphs. Next up, pie charts. Every administrator's favorite thing. A pie chart, by definition, has to be percentages. Even if you do not show the data on the pie chart as percentages, it has to be created with percentages because it's the proportion out of 100 that makes the actual pie piece. I am not going to have you make your own pie charts. Okay, because to actually accurately create a pie chart, you need a compass because you have to actually measure the degrees and actually draw the lines to make it perfect. I'm not going to make you do that. If I was in middle school, I probably would just for the fun of it. But we can use technology to do this. So if you have, most of you might not have Word, Excel, PowerPoint, those things like that. You actually all get it free, by the way. You all have access to Office for free because you're a student here. Just something to keep in mind if you ever need it. However, Google does it free too. So all you need to do to actually make a chart in, say, Google Sheets is just put your data there and say insert chart. And for a pie chart, just tell it with the information you have in it, and it'll make you a nice little pie chart. And the nice thing is, if I was to change this, so notice how originally these were all percentages, right? If I change this to 0.3 and don't change it, now this doesn't add up to 100, so they're not even percentages. It changed the percents on the pie chart. Because now it's looking at these not as percentages, but as just data, which it then has to make a percent to put it in. So now I'm now up to 47.4 over my brother and my sister. But if I change this one back to 25, now they're back to the actual data points that I had. So quick and easy to make pie charts. It can also do, if you change the style, I can change this to a bar chart just by literally clicking on the thing and changing it to a bar chart. Or if I wanted it as columns, it'll change it to columns. So you can quickly do this in Google Sheets or Excel too, if you want to do it there. So if you ever need to make a chart, that's all you have to do. And my administrators still haven't figured out how to do that. I don't know why. All right. Let's look at government spending. Okay, so what's this chart tell you? Oh, I didn't switch back. There we go. What's this chart tell you? Yeah.
We spend the most on Social Security.
Okay. How much taxes do you pay for Social Security? Huh? Yes. So the tax for Social Security is right now. I think it's actually 6.2, but it's close. Like, yeah, it's in the sixes. So I think it's 6.2 right now. It changes, and it shouldn't. So you pay 6.2%, and your employer also pays 6.2%. So if you were self-employed, you have to pay both. You have to pay the 12.4. So when they hire you, when they're looking at your hiring and all the other stuff that goes along with you, that stuff calculates into their end when they're trying to figure out how much it costs to hire you. Not just your salary, it's all the other stuff that goes along with that. All right. So that 38% of the government spending should be covered by that 12.4% Social Security tax. It's not, because the government keeps cutting that instead of increasing that. Was it 20? Actually, it might have been. I think it was in 2000. Actually, it was 2009. I think Trump did it too. Actually, they decided to give everybody a raise at the beginning of the year. They gave everybody like a 2 or 3% raise. All they did is they cut the Social Security tax. So we gave everybody a raise. And then a year later, that raise vanished. So everybody lost 3% of their check, and they were freaking out. So, but that makes up 38% of our government spending. Medicare, the current Medicare tax is 2.9%. And that makes up 28% of our spending. So out of your paycheck, you get 2.9% taken out of your check to pay for Medicare. That's like if you see the breakdown, depending on how your employer does it, they might put it together. But if it says FICA and then Medicare, those are the two different taxes. FICA, Social Security, and Medicare is the separate tax for that. They might put it together on one line. So if you don't have it split, it's just a one line where they combine them. Defense, 16%. Other programs, 12%, and net interest, this is the interest on our national debt, was at 6% that year. Way higher than that now. It's actually approaching the defense level right now for our national debt. All right, so if you were the government and you needed to make sure you were bringing in enough money to cover these things, that would be ideal, right? Because then we're not going more into debt. So in 2015, the government brought in $2.96 trillion and they spent $3.36 trillion. Not quite enough. So let's look at where the money came from. So 47% of the money coming in was your income taxes. 33% were payroll taxes. That's Social Security and Medicare. All right. So how much of the spending was Social Security and Medicare? Combine them. What did you get as a percent? 66%? And only 33% of the money coming in was to cover those. That's why those programs are in so much trouble. Because the money coming in isn't enough to cover what's going on. That's why hopefully at some point they'll figure this thing out, fix it. Otherwise, none of us are getting Social Security. So if you're hoping on it, I plan for something else. Corporate income taxes, 11%. Other taxes, 6%. And excise taxes, 3%. This is what they want to increase, this little portion of the pie right there. They keep talking about how if they increase that part, all the problems will be solved. They would have to like triple that, which they're not going to do. They're going to raise it by maybe a couple, like maybe 5 or 6%, maybe half of what they're going to increase it by. Not going to make that big of a difference. Because they want to cut this portion to make our lives easier, which would be nice. So, how many of you have ever actually seen the tax booklet? Okay, so pretty much everybody here does their taxes online, right? You used to do it by paper. And one of the interesting things is, so next, like February, go to the post office. They actually have to have the booklets for your taxes. And look at one, because on the back of that booklet, or like one of the back pages, they have to have these charts to show you where your money was going. It's required by law. It's also on the IRS's website, but nobody ever goes to the IRS's website. They go to TurboTax or H&R Block. It's like, so, but they'll actually show you where your money is going and where it's coming from. And this is your money, which most people don't realize. This is your money. So knowing where it comes from and stuff is actually important. But those are pie charts. Let's look at one more pie chart. One that's not dealing with government spending. Here's another pie chart. All right. What's the first pie chart talking about? Okay. And how many employees were there? 5 employees. Good. Is that a decent pie chart? Who's making the most money? Or who's making the most sales? Yeah, Brianna. Katie's pretty close. Brianna looks like about a third. Katie looks just like under like a quarter-ish. All right. What about the second pie chart? Avena or Evelina? Yeah, it's Evelyn. Evelina. Evelyn, however you want to pronounce it. Is that a good pie chart? Why? Okay. But it's in essence, it's the same type of data as the first pie chart that we said was good, right? What's the difference between the two? Right. And each employee, when we're looking at frequency distributions and relative frequency distributions, are considered what? What's the pieces of a frequency distribution? What are those things called that we have to have before we can come up with the numbers? Classes. In a pie chart, there's only so many classes that you can have before the chart looks a mess. It isn't useful anymore. Okay? It might be a little more than 5, but it's definitely less than 40. All right? Because once you get to too much, you can't understand what's going on. That's why when we're looking at these, you see a lot of times you'll see other, like other programs. So they just clump a whole bunch of stuff together, right? Or other taxes. They just clump a bunch of stuff together. So they don't list every single type of one on there. So this way the pie chart still is useful and makes sense, but is readable. All right. Okay. Is this a list or a frequency distribution? Why?
Category.
Okay. Anybody want to make an argument for that this is a frequency distribution?
How you can class an individual country. Yeah, because they're individual countries.
Right.
I mean, you could do towns in say country and class it as a country.
So when you're looking at a chart to see if it's a class or if it's a frequency distribution or a list, you have to look at what the data is showing. Okay. Normally in a list, they'll all be there and you'll get one piece of information. So in this case, it's the expenditure per capita. So they've already basically collapsed the entire populations into those things. So the class in this case is the country. Okay. So which country has the highest healthcare costs? Switzerland. Not the United States, which everybody would have assumed. We're close. We're close in there. And actually, I think Switzerland still has a socialized medicine. Not positive. Yes, they do. So every country except for us has universal health care for their population. But it still costs. So, like in Switzerland, it actually costs more than us. What would be the biggest difference between Switzerland and us? They also have a lot less people. They have a lot less people. We actually, like, based on our doctors and everything else, we have some of the best healthcare in the world. Like, people come from all over the world to the United States to get good healthcare. It just costs a lot, and we don't have a way to necessarily pay for it as well as some other countries would. So, but in the end, somebody's still got to pay for this. So this, I wanted to use this chart just because it's a good example of where you think it's a list, but it's not. It's a frequency distribution. You couldn't take this and turn it into a relative frequency distribution because there's no way to divide those necessarily. You could compare them between each other if you wanted to add them up and divide that way, but that is really not that useful in that situation. So that's why they don't do that for this one. All right. Answer.
So with this being a frequency distribution, could you technically take it and deep into it more? Like take the numbers and go like 1,000 then to 2,000 or like 3,000 to 4,000.
Yeah, you could change it. You could actually classify it even more.
Okay.
Yeah, you could definitely do that. So, like, you could always take things and break them down, even like combine them more. It's just a matter of, is that useful? So that'd be more useful if you looked at every country around the, like if they were all listed there, and then you could actually sit there and start organizing them. One year I had my students do a project. God, this was probably almost 15 years ago, actually. Now it was 2008, 2009. I taught a class and I had them, because gas prices were like really high then, like higher than they were recently. They were almost to $5 a gallon. Everybody's like, oh my God, the gas prices in the United States are so expensive. So I had my students actually look at the gas prices in every country around the entire world and convert it to US dollars. So they could figure out like where the most expensive gas was. Europe was way more expensive than us. There were some countries that were at $12 or $13 a gallon.
But you also have to consider they don't really use their own personal.
Absolutely. That's a big difference. But that's because the gas prices are so dang high.
Also, they actually have public transportation.
Yes.
I used to live in Europe. Like it's so much better
Oh,
than
yeah.
being here.
Yeah, they do. Because they actually kept gas prices high, so they actually reinvested that into public transportation, so you don't need to use your car. There was a lot of reasons for that one. Yeah, I'm not going to say the European transportation system is way better than here. But it was like when you're looking at it, so the cheapest gas was in, if I remember right, then it was Venezuela. It was like 7 cents a gallon. Iran was what I think it was like a 9 or 10 cents a gallon. Those are, you got to realize though, those are your major oil producing countries. They produce most of their own oil. So that's where you're looking at it as. It's like you go to Europe, you're going to pay a lot more for gas, but you don't necessarily have to take your car everywhere. Like you can take a train and pretty much go all around Europe if you really wanted to. So, all right. List or frequency table?
Would that be a list? Because I think this table would be like, most and least, or
Oh no, it doesn't necessarily have to be most to least. I would say this one can border on it. Like you could actually make an argument for either one in this case. Because they're really looking at a group, so like they're putting all solar installators together, putting all wind turbine installations together. Those are the classes in that respect. So I would say that those could be classes. We could then break it down more if we wanted to. Is it a relative frequency table? No.
This one, it shows like, I don't know how to explain it. It shows, I don't know how to explain it.
This is why I showed this one, just like the last one. Relative doesn't mean that it is in percents. Relative means that we're comparing it to some other number, right? So like the first one we did, we compared it to the total. We divided them by the 1,250 people. And we found out the relative frequency there. The one where for Parkinson's, we divided it by the 462 people. It didn't add up to 100, but we were able to divide it by to figure out that number. This is a projected increase, not a relative percentage number. So that's why this isn't a relative frequency and this is just a frequency table, because those percentages aren't relative to each other or to some global number that we're using. So they're actually related to themselves because they're looking at from 2016 to 2026 for solar photos or solar panel installations. So based on this table, if you want to go get a job soon, where are you going to go? Those are the green fields. And then after that, healthcare. Actually, I don't even know why they put this. Had to be a stats book, so they had to put that in there for stats. I swear to God. But every other one, like literally green, healthcare and statisticians. Actually, it's not really statisticians. It's data. It's data engineers. That's what they're actually calling them now. It's people that work with data, and that's every business is hiring people. So there is actually going to be an increase in that. Not that I'm saying going into statisticians is a good thing, because you need a lot more math than this one class to do that. So if you like math, that's an option for you. But yeah, that's the there. So yeah, I wanted to show this because I wanted to make you to disconnect the if it's a percent, it's always a relative frequency. All right, I think I'm good for today. Yep. So next class, we're going to look at, so you should be able to do everything up through 3.2 now in Hawks. We're still a day ahead, by the way.
So I nothing's